Welcome to your new unit, Unit D on radicals. It's going to be radical, dudes. Let's start at the very beginning. Some of this is going to be a bit of a review for you, but do you know what? That is A-okay. So lesson 1, simplifying single radicals. Before we start off into a whole bunch of content, let's take down a few definitions. So we have this right here. This is our n. We call this our index. So singular form is index. So when there's only one of them, it's index, but plural form, it's indices. Okay, so if you hear me use the word index, it means that it's referring to one index, whereas plural, I'm going to call them indices. So if I were to say the cubed root of 8 and the fourth root of 16, I would refer to these two things as indices. Whereas, if I just had one of them, I would say, oh, the index here is 3. We have this A underneath here, and I'm just going to highlight it. The A here, that's called our radicand. It's the thing that we're finding the whatever root of. And this whole thing as an entirety, this right here is our radical. Something special to note, if you have an index or if no index, a 2 is implied. So if I say this this one right here, this radical, I would say that that is the square root of 25, which is 5. Okay, whereas if I have an index here of 3 and I'm looking at 8, I would say the cubed root of 8, which is 2, because 2 times 2 times 2 is 8. So let's talk about what a principal square root is. What we say is always give the positive square root when simply evaluating. Okay, so for example, if I were to say the square root of x squared, I'm going to call that the absolute value of x. We're going to go for the positive one. So if I'm just looking at numbers here, so example 1, if I were to ask you for the square root of 36, that is going to be 6. Okay, that's just going to be positive 6, no problem. Or if in example 2 I were to give you the square root of 81, that is simply going to be positive 9. Here's where it gets a little bit complicated or a little bit confusing. If I said x squared is 36, I would have to say that x is both positive and negative 6. Why? Because when we're looking at an equation, we're asking what values are true for x, whereas when we're evaluating an expression, it's different. So evaluating. So when we are evaluating, we simply give the positive. So when we're evaluating, we give the positive. But when we're solving an equation, so this is solving, we're asking the question, what values are true for x? So it's really important that you know the difference between evaluating, where the principal square root applies, or know the difference that from when we're solving, answering the question, what values are true for x? If we want to give a little bit more of a, if we want to give a little bit more of an in-depth example here, if I were to say the square root of 7 minus 10 squared, if I were to simply use this definition here, if I were just to say the thing that's under the bracket, or sorry, the thing that's underneath the radical sign, okay, or the radicand, let's use our real math words, shall we? The radicand is always going to come out positive. So if I were to use that definition, I would just simply say, using this definition here, we would say the square root of 7 minus 10 squared is simply the absolute value of 7 minus 10, which is the absolute value of negative 3, which is 3. So that's what the definition says. Let's use what we know here of BEDMAS, or order of operations. So the square root of negative 3 squared is the square root of 9, and because we always use the positive square root when simply evaluating, we're going to say that this is positive 3. Done. So two ways, one using the definition of principal square root and one using order of operations to get to the same thing. Now, I'm just going to highlight this in yellow because it is an example that exemplifies, is that even a thing? The principal square root. Okay, it's also important here to notice that the pattern also extends. So if I were to get my pen back here, I'm going to say not only does the square root of x squared equal the absolute value of x, but the fourth root of x to the 4 is also the absolute value of x. So let's pause for a second here. If I were to say the fourth root of 16, so what times what times what times what is 16, and all those what's have to be the same, I would say that is going to be positive 2. Whereas, in opposition to that, or in contrast to that, if I were to say x to the power of 4 is 16, I would have to say that x is positive or negative 2. Because if I put in 2 to here, I will get 2 to the power 4 is 16. But negative 2, let's substitute in negative 2. Negative 2 times negative 2 times negative 2 times negative 2. 2 times 2 times 2 times 2 is 16. Negative times a negative is positive. Times a negative is negative. Times a... Oh, hey, Ron! What? How are you doing?
Hi, Tara. I'm doing wonderful, thank you.
Oh, man! Thanks so much for the visit.
All right, well, I'll leave you be because you're busy.
Oh, thanks, Ron. Thank you so much.
All right.
Okay, bye.
Best teacher at Nelson Mac.
Oh, man! Best custodian at Nelson Mac. Woohoo! Oh, man. I just love those visits from Ron. They're really, really great. He keeps my classroom clean, and I appreciate it. So, a negative times a negative is a positive. And then another negative times a negative is a positive. So all the sign here is positive. Another way to say it is that there's an even number of positives, so it's going to be an even number of negatives, so it's going to be positive. Whereas if there was an odd number. Also, we can also extend this to the absolute, the sixth root of x to the 6 is going to be the absolute value of x. Now, you're noticing here, if we're saying that if the pattern extends here, but why not for odd indices? Okay, what about index, if the index is root 3? Let's just show you an example. If I were to take the cubed root of -3, the cubed root of -8, there can only be one answer. That is simply only -2. Why? Because -2 times -2 times -2 is -8. If I were to take the cubed root of +8, that's going to be +2, because 2 times 2 times 2 is 8. So we never have to worry about the principal square root when it comes to odd indices, because we will only have one answer. If I were to have the fifth root of -32, the only answer that it can be is -2. That's it. So let's talk about what the difference is between an entire radical and a mixed radical. An entire radical has perfect square or perfect cube or perfect fourth root, etc. Has perfect square factors. Okay, so for example, the square root of 8. A mixed radical has a coefficient, an integer coefficient, plus non-simplifiable. I'm just going to put that in quotation marks because I don't think that's a real word. Non-simplifiable or radicand. So for example, if I were to say -3 root 5, I don't have any way of simplifying this down. Whereas with the 8, I can say that that is 2 times 4. So if I were to say, which is the same thing as root 2 times the square root of 4, which is 2 root 2, just like that, because the square root of 4 is 2, and root 2 is simply the same as root 2.